It's going to stem from our two properties where we had, this out of the way real quick. We had our two properties where we had the log base b of b was 1, and log base b of 1 is 0. We basically wind up using these two properties to get our ordered pairs. Okay, we're still going to have parent and shift, but what happens is we're only going to have 2 points. Okay. We're only going to have to graph 2 points for these things, which is nice. It's not a lot of work then. Okay. Logarithms, it still has its same properties of your h's and k's. So your generic formula for your parent, or excuse me, for the whole shift thing, we log base b x minus h plus k. Again, your h and your k is your horizontal and your vertical shifts as they go through. Your line x equals h is your vertical asymptote, and the domain is always x is greater than h. Okay. Excuse me. And then the last little bit, if the b value, your base, is greater than 1, it moves up and right. Basically, it does this. B is greater than 1, it does something like this. And if it's between 0 and 1, it moves down and to the right. That's the only two ways that these graphs go. Good riddance. Okay, that's the only two ways these graphs go. I joke with like the difference between exponential and with logarithms is that yes, your logs grow from trees and trees grow up and down. That's why there's asymptotes that are vertical. Yes, ma'am. You can't have negative bases. We don't have negative bases, and you can't take a logarithm of a negative value. Okay? That's how all this stuff works itself out. That's why you get that vertical asymptote you can't go past. So it stops you. Okay? So again, what happens, we'll have parent and shift, and it works out rather cleanly. And let's see here. I'm going to do log. We'll do this as an example. Log base 1/3 x minus 2 minus 1. Okay? And we'll use this as our example of how to go through all of it. So what happens here is we have our parent will have a shift. Excuse me. When we do our parent stuff, we know it's going to be x plus 2, y minus 1. We know that that's what the ordered pair is going to do because of the h and the k. When I look at the parent, I'm basically looking at this. Y equals log 1/3 x. That's the parent. Get rid of the h, get rid of the k. From here, we worry about the two properties. The two properties that we're talking about again are the log base b of b is 1, and log base b of 1 is 0. Okay. So what happens is, I think I have it on the next one. We're going to use these guys for your ordered pairs for your parent. Your parent graphs will always use these as your ordered pairs. Whatever b is, comma 1, then it's 1 and 0. So honestly, the only ordered pair you have to figure out is the b. Yes. That's what's nice about logarithms. Where you're graphing logarithms are really fast. Okay? So we know that our two ordered pairs is, if you think about it, if I put in this up real quick. If I put in 1/3, I'd get 1/3, a log of 1/3 of 1/3. Well, what's the log base 1/3 of 1/3? That means 1/3, what power is 1/3? 1. That's where that comes from. Okay. So your ordered pair would be 1/3 and 1. And then again, if I used 1, 1/3 to what power is 1? 0. And that's where that goes. So those are my two ordered pairs that I can work with. And then I shift them. Again, am I going to use a top-heavy fraction or a mixed number here? Use a mixed number. It's just cleaner. Okay. So you have a mixed number. It would be at 2 1/3 and 0, 3 and -1. What's that? Logarithms are pretty quick to do that. They really are. Right? That's why we didn't need to spend a whole day on it. So when we go to plot these, excuse me, let's put the screen here. And I'll use a graph for one shot. We know that we have an asymptote at x equals 2. Vertical asymptote at x equals 2. But when you have your parent, though, where's your asymptote for your parent? At 0, yeah. So you have your original would be at 0. 1/3 and 1, here-ish. 1 and 0. And again, since this is the b value is between 0 and 1, it's moving down and right. I only have 2 points I can plot, so I just plot them. It does that. And then I just go and graph the other part. The other shift then would be at 2 1/3 and 0. 2 1/3, 0. New asymptote. 3 and -1. Solid line. And there you go. Log. It's heavy, it's wood. Log. It's better than bad, it's good. You're gonna love it, log. Get your log. Log. You guys aren't very excited about the log song. It's very sad. There's another version of it, it's the action log. I'll have to look that one up for you. What's wrong? We did. There's only one asymptote, it's vertical at 2. Oh. Yeah, your asymptote's at 2, so this is my asymptote. And my domain is x is greater than 2. My range is all real. Domain and range for logs. Your domain is always going to be x, whatever is greater than your h value. And your range is always all real. Logs are easy to graph. Okay, we'll do one more, then we'll switch to properties. Let's see. Let's try log base 4 of x plus 3 minus 5. Let's make it simple. And then from there, we do our h's and k's and all that fun stuff. We know our parent, b and 1, 1 and 0. Our shift. What's my x value, or sorry, my h value now? -3, very good. I just want to remind you, you saw the positive, it's opposite. So the shift is just going to go x minus 3, y minus 5. So our parent function, our base is what? 4. So our first order pair will be at 4 and 1, and then 1 and 0.
and then I shift it. All right, pace yourself now. 4 minus 3.
1.
I know, that was a lot. It was a lot. Good job. 1 minus 5. Use the calculator. Oh, speaking of, would you get a calculator for these?
No, you would not get a cut.
All right, here we go. Ready? 1 minus 3.
-2. And we honor roll it.
0 minus 5.
5.
So proud of you. So proud of you. Where's your asymptote? The shifted one would be at -3. Your domain then would be all values of x that are greater than -3. And your range is real. Okay. Again, as we go into these things, I'm just going to do it by hand. It's easier. Parent, 4 and 1. 1 and 0. And as you can tell, it's moving up and right. Shift it. We now go to asymptote at x is -3. Ordered pairs, 1, -4. Oops. -2, -5. And away we go. Not to scale. Okay. Yay, graphing. There will be 13 questions about graphing on the test, just so you guys are aware, because it's that easy. So let's talk about properties. Properties of logarithms, which means there's properties. Just like we had exponent rules and things like that, there are certain things that we can do with logs as well. There's basically 3 of them, and what we do is we work with them in terms of what are called condensing, making them smaller, expanding them, making them larger. The reason we have to worry about condensing and expanding so that way when we get to some equation stuff, we're able to do some extra, a couple extra steps. So basically we wind up with these 3 simple properties. What happens here is that I'm writing it up the way that the book does. Think of it this way. You have log base b of u times v. Okay. You can split that apart into 2 separate logarithms with a plus sign. Okay. For example, if I'm looking at one like this, I'm going to split this, I'll go back to it. If I'm looking at that, think of this in terms of, bless you, if I say it's log base 3 of 4x, that means I can split that up into 2 logs. And it just looks like that. It just pulls it apart. Okay. I know that was tough. I know, it's a lot.
What's the purpose of that?
Okay, we'll get there. All right. The other one is with division. Log base b of u divided by v. It splits it apart into 2 logs in subtraction. Please turn off your notifications. Okay. Same idea. If I have log base 1/2 of x over y, it's the same thing as saying log 1/2 x minus log 1/2 of y. That's all that looks like. Okay. The importance of this stuff comes into play when you have multiple numbers, where you can rewrite numbers as composites, like 12 is 4 and 3. So if you had a log base 4 of 12, you can split into log base 4 of 4 plus log base 4 of 3, so you can simplify it out a little bit. That's where a lot of this comes from. Okay. Also, back in my day, before we had these calculators with the alpha window 5s, you had to be able to do what was called change of base. And most calculators just had the traditional log button. And the traditional log button, if you guys remember from yesterday, was log base 10. So you had to figure out, there had to be a way to convert base 10 into all the different bases. So there's this thing called change of base, and it kind of stems from these properties. And the last property we'll look at deals with degrees. So log base b of u to some nth power just means that the exponent goes out in front. For example, excuse me, if I have log base 2 of x to the 5th, that just means the same as writing 5 log base 2 of x. Okay. So 3 properties. Log. Come on, guys. Let's yell at her. You walking in? No.
Actually, if it goes off again, we can just break it.
Your phone's going up.
Where's the button calculator? That's where
Math. Just in math. And then there's extra. Oh, you could have asked. I would have told you that. Did you hear us yell at you?
Yeah.
Not terrible so far? I don't know. Well, at least I hope that it's not terrible. I should say, phrase that. So let's look at a couple examples then. What happens then is we're going to be able to take and rewrite these things. Excuse me. So if I have log base 3 of 3 times 9, I can use the properties logarithms to help simplify that out. Okay. So that means that I can write this log base 3 of 3 plus log base 3 of 9. What's log base 3 of 3? The height. It's 1, right? Yeah, it's 1. Okay. Now that's 1, and log base 3 of 9 is what?
3.
Ooh, it's 2. Remember, this is the same thing as saying log base 3 of 3 squared. Okay. And then those bases come through. Now you can do one of two things here. We know the property here, log base 3 of the same base, that exponent drops, doesn't it? Watch what happens if I did the other property where it's the exponent of it. I can put the 2 out front. And what's log base 3 of 3? Yeah, it still becomes 1. Okay. So there's a couple of ways you can do this. So you get 1 plus 2, otherwise known as? Or better yet, what's 3 times 9? 27. 27 is 3 to what power?
3 to the 3rd.
So log base 3 of 3 to the 3rd is? It's 3.
Oh, because 3 is 5. Wait, so how can we know just do it like that? Oh my gosh.
There's other ways. There's just showing how the properties work. There's just other ways to do it. Okay. Log base 2 of 4 to the 5th. Same idea. Let's split it out. Well, maybe I should do this real quick before I forget. Put these on a different one. All right, let's follow the property rules. What do I do with the 5? Bring it out front, okay? If we bring it out front, we get 5 log base 2 of 4. Well, 4 is 2 to what power? 2 squared, right? Now, what does that log portion simplify to be? The 2. So you wind up with 5 times 2, which is 10. Okay? Again, there's other ways of doing it. I could have rewritten this right away. 4 is 2 squared. 2 times 5 is 10. Log base 2 of 2 to the 10th is just... Okay. It's math magical. All right. Let's use the properties here. Log base 3 of 1 divided by 3. I'm going to split it apart and rewrite it as separate logs. So you get log base 3 of 1 minus log base 3 of 3. What's log base 3 of 1 is 0, and log base 3 of 3 is 1. What's 0 minus 1? Which isn't that 3 to the negative 1 is 1/3?
Oh my gosh, these are so much fun. They're not fun, but they're like.
Okay. Burn the witch. Once again, let's split this next one up into a couple of different steps, just to show how it's going to work itself through. Do you guys agree that there is exponent and division?
Yeah.
Okay. Now the division portion is in parentheses, isn't it? Okay. So what happens is if I bring the exponent down, before I split my division into 2 parts, got to make sure to put parentheses to both parts. Okay. So now if I rewrite the next log, I have log base 5 of 1 minus log base 5 of 5. And log base 5 of 1 is 0. So you get 3 times 0 minus 1, which is negative 3.
It's not organized.
Well, it could be. Raylan, you just don't trust me, do you?
No, I really don't. I rely on it.
All right, let's expand. That was condensing. Let's expand. Okay. Same thing. We're going to expand this. We're going to rewrite this as multiple logs. So what they're saying here is assuming that x and y are positive. In order for logarithms to work, you have to take logs of positive values. You can't take negative values of logs. It doesn't work. Okay. So when you look at this problem, you've got 7 times x to the 3rd, all divided by 4. Okay. So this is kind of where, when you start expanding this stuff out, where the parentheses come into play a little bit. What has the exponent?
Yeah.
Just the x, right? Now, the numerator has 2 parts to it. Those 2 parts are being divided by the denominator, correct? So the 2 parts in the numerator, when I break it apart into multiple logs, has to get parentheses. That's the trick. So, first of all, do you guys agree if I just write it as log base 2 of 7 plus log base 2 of x cubed? That's my numerator.
Yes. Yeah.
What's the next step I can do with the exponent?
You bring it out.
Bring it out to front of which log? The second one. So, if you want, could you have done that right away?
Yeah.
Yeah, and eventually you'll be okay to do that. I just thought I would stop, show you by just splitting apart the first 2, looking at it going, oh, I can rewrite that one in front of it and be done. Now, that's my whole numerator. Now I subtract my denominator, log base 2 of y. By grouping the numerator together, it allows you to see where they're all coming from. Right, that's what that does. What's that? Yes. Still trusting me at all yet? Ish?
Well, these are easy. Those were easy. Let's expand this one. Okay. How many parts are there? How many logs should you have when you're done? 4, right? Okay. Is there any division? No. It's all multiplication, right? And 1 exponent. Okay. So if I break this out, I have 4 logs to write. What's my base? Do I have to write it? For my second log, what am I going to do? Yep. Yeah. Weird, but yeah. Condense. Condensing is where things can get a little messy. You just got to be careful with it. Take your time as you're condensing. Remember, whenever you see condense, we're trying to rewrite it as few logs as possible, which means you should be able to write it as one singular log. So we have log of 6 plus 2 log of 2 minus log of 3. Now, one thing that I would say is that should have parentheses around this first 2. So between the first 2 logs, you have a plus sign, which means what's happening with those numbers? Multiplying. Okay. So I have a log. It's base 10, so I don't have to write it. My numerator is going to be 6 times what? 4. Good. Or right now I'm just writing it as 2 squared real quick. Okay. Are we all right with that? Yeah. What am I divided by? 3. What does this simplify to equal? Very good. Then you simplify it out, you get log of 8. Okay. That's what it looks like with the number stuff. Just go piece by piece. Don't try to do too much at once. Do that one first. Condense it. Excuse me. Did you get log of the square root of x over 4?
I mean, I guess I did. Oh,
Is x to the 1/2 square root? Yeah. If you wrote x to the 1/2, are you wrong? No.
But you're more right if you do that.
No, either one's fine.
But you're cooler if you do that.
Sure. That's why I wrote it as that way, just to mess with you.
So would this be right? Or would we have to have the log?
Oh, you just want 1 log, because you're writing it as 1 log. Okay. When you condense things, you should only have 1 log when you're done. Okay. All right. So let's make it weird. Where is this going to let us get to eventually?
Murder.
Not murder. As much as we want to murder, we don't want to. Speaking of murder, hey, just joking. She probably heard me yelling out the time. Anyway, what's natural log stand for? Log base E, okay. So doesn't that mean that that's all the same base, even though it says natural log? Which means the same properties apply when you're condensing and working through it. Okay. So when I'm looking at this, is there anything I can condense? What's that? Correct. I can condense the stuff that's on the right side. You have natural log of x minus 1 minus natural log of x plus 1. Which means on the right-hand side here, I can rewrite this, well, the natural log x plus 5 is natural log x minus 1 over x plus 1. Everybody okay with that?
Yes.
Okay. What could I do to get rid of the natural log? Very good. You would E it, if you will. Because remember, natural log is log base E, so if I E both sides, what happens? I get rid of them. And I'm left with then and then technically you can cross multiply, set aside, you put a 0 and find x, couldn't you? We're not there yet, but that's kind of where this stuff heads towards. By utilizing properties of logs, you can condense things in order to solve equations and work your way through. That's kind of what we're heading towards. All right? Not terrible? So I would like you guys to try 2 graphs, and then I want you to do some of these log properties. The PDF file for the graph stuff is already on today's. I had not moved the PDF file for the condensing and other log stuff yet. It's still on tomorrow's date, so I'll just slide that over next hour. What I want you to do then on 8.4, don't use graph paper or anything for this. I don't even have I'll do these 2. So let's do log graph those 2. I just made those 2 up. They don't do any H's and K's in the book, which is weird, so I just want to make sure you see both an H and a K. And then in 8.5, that's on page 496, let's do 30 through 56 evens. One of them we're expanding, half of those are expanding, the other half are condensing, and go from there. And then tomorrow, I've got some crazier ones to look at on a sheet there. Good times. And then we should be able to we might actually be able to start a little bit of the equation stuff tomorrow night, or tomorrow morning, sorry, for what day it is. And get going through it, so we'll be all right. Eventually. And you guys all hang out with me at basketball practice with my kids. Hey, what's his birthday this week? Yeah, I don't coach basketball. I coach baseball. Yes, ma'am. No. You're welcome. Get the honor roll.